Well, the goal today is to find the average rate of change of a function relative to two given x coordinates. So here's what I want to point out. When you're talking about average rate of change, you're really talking about the slope of a line through 2 points. And you know this, that slope m equals the difference of two y coordinates divided by the difference of two x coordinates. So the average rate of change corresponds to the difference in this case, g of x sub 2 minus g of x sub 1 all over x sub 2 minus x sub 1. Now what is g? Well, in this case, g of x equals 3x squared minus 2x plus 3. And the x coordinates we're talking about are x sub 1, for example, we'll claim equals negative 2, and x sub 2 equals 1. So we have to find, we know what the x coordinates are, we have to find g of negative 2. So g of whatever equals 3 times whatever squared minus 2 times whatever plus 3. So if we put a negative 2 here, then we have to put a negative 2 here and here. So this equals, when we square this, we get 4, and 3 times 4 is 12. Now minus 2 times minus 2 is a plus 4. Plus 3 equals 19. So now we know g of negative 2 equals 19. Our next task is to compute g of 1. So g of whatever equals 3 times whatever squared minus 2 times whatever plus 3. If I put a 1 here, I have to put a 1 here and a 1 there. So 1 squared is 1, 3 times 1 is 3, minus 2 times 1 is minus 2, and plus 3, and this equals 6 minus 2 is 4. So g of 1 equals 4, and we have our second y. Well, I also must point out that y equals g of x. And as we said, the average rate of change in this case equals g of 1 minus g of negative 2 all over 1 minus a minus 2. And we know this, that g of negative 2 equals 19, and g of 1 equals 4. So our ordered pairs are negative 2, 19, and 1, 4. So I'm going to write the average rate of change equals, in place of g of 1, we'll install the value 4, minus, in place of g of negative 2, we'll install the value 19. And downstairs we have a 1 minus a minus 2 gives us a plus 2. And simplifying this, we 4 minus 19 is negative 15 over 3, and that equals 5, and that's a negative 5, and that's our average rate of change between the two given points on the function g of x. Our next task is to find the equation of the secant line containing the ordered pairs -2, g of -2, and 1, g of 1. Well, to do that we need the slope. Well, the average rate of change is the slope of the line through those 2 points, and that line is called the secant line. So m equals -5. The two ordered pairs are -2, 19, and 1, 4. Now we have the slope, we have two ordered pairs. We only need one of these ordered pairs, and the slope and the point-slope equation of a line, which is y minus y sub 1 equals m times x minus x sub 1, and we can come up with the equation of the secant line through these 2 points. So I can choose either ordered pair and this slope to come up with the equation of this line. Since these values are easier to work with, I'll choose the ordered pair 1, 4. So y minus 4 equals -5 times x minus, and the x coordinate is 1. So y equals, adding 4 to both sides, and distributing this -5x, and a -5 times a -1 is +5. And now gathering up like terms, we get 4 and 5 is 9 minus 5x. And this is the equation of the secant line through the ordered pairs -2, 19, and 1, 4, and we're done.